Alright, this is Unit 7, Day 9, completing the square to find roots. So you're still in the quadratic unit. Quadratic is an equation that has a square in it. Way back in the beginning of the year when you learned how to factor, you learned how to find the roots by setting each one of those factors equal to 0 once you found them. Some quadratics can be factored, but not all of them. The method that you learned on Unit 7, Day 8 is only for specific kinds of quadratics. It tends to provide a little bit of a shortcut if you can do it that way. But again, it won't work for all of them. So there are two methods that work for all of them. One is called completing the square, which is this lesson, and another one's quadratic formula, which is the next lesson. Completing the square has 4 steps. There is a question on Regents exams every year that have something to do with completing the square. So this is a process that you're going to need to know. They do not tell you the steps on the Regents. This is something they expect you to memorize. So when you solve a quadratic equation algebraically, you are finding the roots. Remember, roots are where the parabola crosses the x-axis. You have learned how to do this with factoring already. And what you were doing on Day 8 lesson was also finding the roots of special kinds of parabolas. But now we're going to do completing the square, because like it says, not all quadratic equations can be solved using factoring, but all of them can be solved using completing the square. That being said, completing the square is a process. Some equations, the numbers are nice. And in other equations, if you try to use completing the square, you're going to make yourself some nasty fractions and decimals. So this is not a method that I would suggest that you jump to right away, but you do need to know how to use it because of New York State. And again, you will use it in a few different circumstances in Algebra 2. All right, so example 1. Remember that the standard form of a quadratic is y equals ax squared plus bx plus c. We learned that and used that when we were finding the axis of symmetry and vertex algebraically. We used the a and the b in that formula. Well, it's good to know the a, the b, and the c because that's what we need to refer to those. So example 1 says find the roots of 0 equals x squared minus 2x minus 15. First thing you want to do is to put the constant alone on one side of the equal sign. So first thing I did was I crossed that off and I put the equal 0 over here because that's the way I prefer to see it. And you can have the equal sign on whatever side that you wish. Now, any other time you solve a quadratic, you're pretty much setting the equation equal to 0. Completing the square is the exception to that rule. So this time you want the constant to be by itself. So we are going to add the 15 to both sides, and that will give us the x squared minus 2x equals 15. The next step is to take half the b and square it. Now recall, the b is the number touching the x term, not the x, just the number touching the x. So in our case, negative 2 is touching the x, so negative 2 is the b. So we take half of it, which means divide it by 2. Negative 2 divided by 2 is negative 1. It's a negative number. Make sure you hug it, put it in parentheses. And you want to square that number, and that equals 1. Now, even though this is very simple math, you want to write these steps on your paper, and there's a really big reason for that other than just showing your work. Once you get that number, the 1, you're going to add it to both sides of the equation as shown here. So you've got the x squared minus 2x, so you're going to add 1 to the end of that. And you're also going to add 1 to the 15, because remember, whatever you do to an equation, you've got to do it to both sides. Now what you have done, and what completing the square does, is it creates what we call a perfect square trinomial. So a trinomial is 3 terms, and a perfect square means once you get done factoring it, you end up with the same factor twice. So if you try to figure out what multiplied to 1 and added to the negative 2 like you did in factoring, well, 1 times 1 is 1. But to make a negative 2, I need to make both these negative. So then you'd have x squared minus 1x plus 1. Make groups of 2 for those of you who do grouping. Pull out the GCF, you get x and x minus 1. GCF of this group is -1, and you get x minus 1. So when you get done factoring, you'd have x minus 1, and then the little GCFs are also x minus 1. So you get x minus 1 twice, which is why in this step we write it as x minus 1 squared, because we have 2 of them. Now, you don't have to go through all this grouping stuff, okay? You don't have to do that when you do completing the square. Completing the square makes this getting the same term twice happen. It's by design. And if you can remember that what you got when you took half the b up here, that -1, that will always go in your parenthesis when you factor it. So you don't even have to worry about the grouping. Whatever your half b is guaranteed to be that factor. Just stick it in the parentheses. So x minus 1 squared is equal to 16. Now, this is where what we did yesterday, or the previous lesson, comes in. I have parentheses squared. So this is one of those special cases where I just have an item squared. I can square root both sides. And when I square root both sides, the square cancels with the radical and leaves me with the x minus 1. And remember, when you add a square root to a problem, you get a positive and a negative. So positive and negative, square root of 16 is 4. So that leaves me at this step. Now I have to get x alone. So what I do here, since I don't have any radicals, I know I'm going to have to separate my problems anyway. So I separated them now. So x minus 1 could equal a positive 4, but x minus 1 could also equal a negative 4. And then I solve both of those. So add 1, x equals 5. Add 1, x equals -3. And you have now solved this by completing the square. Okay. Is it the fastest method? No. Okay. Is it a method you need to know? Yes. All right. Now, they could throw one little monkey wrench into this. All right, and that's what I have marked right here. The coefficient in front of the x squared term must be a 1 for you to complete the square. If you have any number touching your x squared, your first step is to divide it out and get rid of it. Then you're going to do what we just did on that problem. So let's take a look at that. Solve by completing the square. So I notice first thing that there's a number touching my x squared, and that is not allowed for completing the square. So I am going to divide absolutely every term by 3. So divide by 3, divide by 3, divide by 3, and divide by 3. And yes, I know that 0 divided by 3 is going to be 0, but if I don't show New York State that I'm dividing everybody by 3, they're going to ding me for inappropriate work, because I have to divide everybody for the laws of equations. So these 3's will cancel out. X squared minus 12x minus 4 equals 0. So now that my x squared does not have a coefficient other than 1, I am ready to complete the square. First step, move your constant to the other side. So we're going to add 4. So you get x squared minus 12x equals 4. Second step, somewhere off to the side, take your b term, take half of it and square it. So my b term is the -12 that's touching the x, so I divide it by 2. That gives me a -6, and since it's negative, I have to hug it before I square it. -6 squared is 36. So now I'm going to take that 36 and add it to both sides of my equation. So x squared minus 12x plus 36 equals 4 plus 36. So I'm adding it to both sides. Now I want to add these two guys together, and we'll just call it 40. And this is the only time where you factor something without the equation being set equal to 0. Completing the square is the only time you factor without setting it equal to 0. I am not even going to waste my time thinking about the factors. I don't want to. I don't want to do factor by grouping. So if I want to skip that, then I am going to remember that this number here, before I squared it, is what goes in my parenthesis with my x. So this is going to be x minus 6 squared. That is by design. Completing the square makes it happen. By the way, this polynomial, x squared minus 12x plus 36, is what we call a perfect square trinomial. I've seen that phrase show up once or twice on the Regents, so I'm going to keep pointing that out. The reason it's a perfect square is because when I factor it, I get the same thing, so it gets squared. All right, the step after this, square root both sides. So the square knocks off the radical, and I get x minus 6. And then I automatically get positive negative. Now, square root of 40. If I type that in my calculator, I get a yucky decimal. We don't want yucky decimals. We're probably going to be asked for exact answers anyway. So off here on the side, I need to simplify the square root of 40. 2 times 20, 2 times 10, 2 times 5. There's my hockey stick. Groups of 2. Yeah, I got one group of 2. So cross that off. A 2 comes to the outside. And then the 2 and the 5 get multiplied back together to make a 10 on the inside. Now this time, since I have a radical over there, I am not going to separate my two equations because I can't add them together anyway. So right now I'm just going to do an add 6. And like the previous lesson, okay, mathematicians like you to put the pretty numbers first and the ugly irrationals after. And there are your two answers, 6 plus 2 root 10 and 6 minus 2 root 10. You can separate them if you want, but it's not required. There's 4 steps to completing the square, but back when you started learning factor by grouping, you're like, oh, I'm never going to get the hang of this, and now it's automatic. Once you do completing the square enough, the 4 steps will be automatic, but again, you have to remember what they are. All right, here we go, example 3. There is nothing touching my x squared, so I do not need to divide. First step, move the constant to the other side. So x squared minus 16x equals negative 48. Next step is to take half the b and square it. So you take the negative 16, divide it by 2, which is negative 8. Wrap it in parentheses and square it. Negative 8 times negative 8 is 64. Take that 64, add it to both sides. Okay, now clean up the right side and actually add them together. That's going to give you 16. Now that you have a perfect square trinomial here, you're going to factor it, but you're not going to think too hard. You're going to have an x. And when you took your half b, before you squared it, you had a negative 8. So that's what goes inside the parentheses for your factors. Don't even have to work at it. All right, from here, square root both sides. The square and the square root cancel. That leaves me with an x minus 8 equals positive or negative before I forget about it. And the square root of 16 comes out pretty. Comes out to be a 4. So because it comes out pretty, I need to get 2 normal looking answers. So I'm going to separate my equations right now. X minus 8 could equal a positive 4, but the x minus 8 could also equal a negative 4. Add 8 to both sides. X could equal 12. Add 8 to both sides. X could also equal a positive 4. All right, completing the square. It's tedious. It's got 4 steps. I walked you through 3 problems. We are asking you to try 4 of them for the homework that accompanies day 9. Good luck.